Alright, welcome back. So we are looking at solving homogeneous differential equations. Solving a homogeneous differential equation. So a homogeneous differential equation, this, alright, can be transformed into an equation of what? A separable variable in u and x, from which its solution is obtained by integration. That is why I said that your calculus 1 and 2 is really interested as far as this course is what concerned. So let's look at this theory, right? Consider the first order homogeneous differential equation. Then the change of variable. Then we can do a change of what? Variable. And that is y is equal to what? Ux. And that change of variable is equal to y is equal to what? Ux. Alright. Alright. Transform it into, you are going to use this to transform it into a separable equation in the variable u and x. So let's look at the proof. Okay. So this equation is said to be a homogeneous, then by definition, why are we saying that this is said to be a homogeneous? We can see that when we attach lambda with x and lambda with y, we can get a degree of what? 0. That means that we can factor it what? Out. And in such case, it's said to be a homogeneous what? Differential equation. So here, we can let lambda be equal to 1 over x. So all that you do is that wherever you see lambda, put 1 over x here. Alright, so we get this lambda is 1 over x times lambda x, comma 1 over x times lambda y. Alright, sorry. Oh, 1 over x, that is alright. So here we get x comma y to be equal to this will cancel this. So this we get lambda. And also here we will also get lambda is equal to 1 over x. So lambda will not come again. Alright. So here we are going to get 1. And also with this side we are going to get y over x. Y over x. Alright, let's move on. So this implies that dy, what we have here implies that dy dx is equal to what? f1 comma y over what? X. So here we are going to do something. We are going to put y. We are going to put y to be equal to ux. In such case, you see we have y is equal to x. So this in some books, they will make it u to be equal to y over s, which is the same thing. Alright. So here, after putting u to be equal to y over x or y is equal to ux, what we do is that we want to define this dy dx. So we are going to differentiate this as respect to what? X. That is why even if we set u to be equal to y over x, you will still need to make y stand alone. So dy dx is equal to, for this is going to be a product what? U. Because this is a function u, this is a function what? X. So product u. So you leave this, differentiate the second one, you get 1 plus. Now you leave this, then you differentiate this, where you get du dx. Alright, so this is what we are going to get for dy dx. So what we are going to do is that we are going to do the substitution back. Let me call this equation A and call this equation B. So we are going to do the substitution back to this. Alright, so when you see dy dx here, you put this one there. Please, this is a generalized thing I'm introducing to you. We are going to use the same techniques or the same concept in solving these questions here. Alright. Alright, so let's continue. So by substitution, whenever we see dy dx here, we put the whole of this there. So u plus s du dx is now going to be equal to the right hand side, which is f1 comma y over s. So that is what we are going to do. So now we are transforming. We can see that we are now transforming this differential equation to a separable differential equation, so that we can solve, or we are now transforming this homogeneous differential equation. The idea is that this is a homogeneous equation, and in such case, for you to solve it, you need to transform it to a separable differential equation before you can solve it. Alright, so that is what we are doing. So now, having this, let's continue by transforming it. Alright. So here we can now, we have already set this to be equal to u. We have already set this to be equal to u. And that is what we have there. Alright, so we now have this, and with this we can let s du ds stand alone, so that we get 1 comma u minus u. 1 comma u minus u. So I believe you can notice that equation. I believe you can notice this equation. And that is what is separable. And separating the variable, we can also have, what I'm saying is that it's a separable. We have now gotten to a separable differential equation. So we can now separate this by saying that here we are going to get 1 over, okay, we are going to get du here to be equal to cross multiply, you get the s here. Alright, and this s will be 1 over s here, and this, the whole of this will be 1 comma u minus what? U. Alright, so this is what? A separable differential equation. So we then integrate what? Both sides of the what? Equation. We now integrate both sides of the equation. So we then going to have here, when you integrate this, you see, with this is a whole lot of stuff. So let's leave this one over. This is just a generalization. So let's leave this one minus u du to be equal to, here we are going to get ln x plus what? C. Okay, we are going to get ln s plus c. We are going to get ln s plus c. And we know that with this we can combine it, alright? We can combine it. Okay, let's move on. So we now have ln. Now this, let's change this one to ln c. And you know what? whether plus or minus is still a constant, alright? It's still a constant. So I would like to let it be negative. So lane C. And with this, you are going to get 1 over f1 comma u minus u, alright, du. So, sorry, integral, alright, so that's what we have, alright. So here we get the du here to be equal to ln s over c, ln s over c. Alright, so having this, we can take natural log of both sides. And when we take natural log of both sides, here we are going to get natural log of 1 over f1 comma u minus u du to be equal to here, we are going to get s over what? C. So we can multiply, or we can do cross multiplication. So this will multiply this. So in all, we are going to get s to be equal to c e integral of 1 over f1 comma u minus u du. Alright, so that is it. So to get the solution in terms of s and y, after integration, we substitute after integration, we substitute the u, alright, because we know that u is equal to what? Y over x. So to get your solution in terms of s and y, we do the substitution of u, and that becomes our final answer. But don't forget that here, since we have seen it, this becomes what? A general what? Solution. This becomes a general solution. So now, that is all for that. This is just a generalization. Let's see how we are going to solve these questions here. Alright. So show that the following equation are homogeneous and solve them. So let's look at how we are going to deal with it. And the approach we go by in the general form is the same way that we used to what? Solve this. So let's see how we are going to do it. A. Alright, so we have this divide here. S over s minus y. So to verify this, we know that this is the same as s comma y to be equal to s minus y. Alright. So lambda s comma lambda y is going to be equal to lambda s over lambda s minus lambda y. And here we are going to get lambda s over lambda s minus y. And with this, you are going to get lambda raised to power 0 s minus y. So surely this is a homogeneous differential equation. This is a homogeneous differential equation. So we can now go and solve it. And how do we do that? Alright. Okay, I'm coming. Okay, so let us now solve. So we know what to do firstly. We know we have dy dx to be equal to s over s minus y. And we have verified that it's a homogeneous equation. And for that matter, we can what? Solve it. Alright, so So here, the first thing to do is that we let our y to be equal to, or we have to process whether you let y to be equal to u over, you let y to be equal to us, or u is equal to y over what? S. Okay. So the second step to do is to differentiate this. Okay. So this is the first step. The second step is to differentiate this. So dy dx is going to be equal to, this is a product rule. Don't choose this. It's a product rule. So u plus s du ds. Yes, it's always this. Because when you differentiate this, it's going to be always this. But you don't need to chew it. It won't help you. Alright. So the third step is for you to go and do the substitution back. So when you see dy ds, you put the whole of this here. So you get u plus s du dx is going to be equal to s over s minus y. And what is y? And y is going to be what? us. So you can see that we have get rid of all the function y from in it. And now we have the function in terms of what? S and u. So it means that we are transforming a homogeneous equation to a separable differential equation, so that we can solve it by what? Separable. So to solve the homogeneous differential equation, it's all about transforming an equation to a separable. That is all. That is why we first learned separable differential equation. So here we get x du dx to be equal to, let it go to this side. We get x over s minus us minus u when this moves to the other side. Okay, so you know what's happening here. Alright, let's move on. So here what we do is that we have s du ds to be equal to s over, now here we can factor s out. Please, your algebra is also interested here. 1 minus u. Alright, and we can see that this will cancel out this. So we get s du ds to be equal to 1 over 1 minus u minus u. Alright, so here, let's apply our algebra. Let's transform, or let's maintain the same what? Denominator. So to do that, to maintain the same denominator, 1 over 1 minus u minus, we are going to multiply this by what? 1. And it's the same as that. To multiply this u by 1 is the same as 1 minus u, because we want to get the same what? Denominator. So this is still the same thing. We haven't changed anything. And this one we get 1 minus u, all these over 1 minus u. We have achieved the same denominator. Alright. So the fourth stage is where we are. That is what? Solving it by what? A separable differential equation. So right after doing the substitution, you have just transformed it to a separable. S du ds is going to be equal to, here 1 minus this time is u. Again, positive. U times this u squared over what we have here is what? 1 minus what? U. Alright. So here is where we are. Okay, so now let's move on. So now having this, then we can have the u here to be equal to ds, and we get 1 over s here, and with this, alright, with this, we are going to get 1 minus u on top here, then we get 1 minus, or u squared minus u plus 1. U squared minus u plus 1. Alright? And what is this going to give you when you factorize it? Alright, so we continue. Now we can see that when you try to factorize this, alright, you can't do this by what? A factorization. So, and by completing of square root, you're going to get something that's not going to help to clear up this. So let's go straight to the point. It's now separable. So we integrate both sides. Alright. And when we integrate both sides, we're going to get integral of 1 minus u over u squared minus u plus 1. Alright. Du, which is equal to ln s plus what? C. Alright. So here we have to take the left hand side and what? Differentiate it. Now, in case you have forgotten your calculus 1, then please, I'm sorry, okay? In case, sorry, your calculus 2, in case you have forgotten your calculus 2, in case you remember, we have something, a technique that says that if you have a function of u over q to the function of u, this is going to be equal to a, this is going to be equal to a q u plus b over q u. Alright, so this means that we are going to replace the numerator here by this and the denominator here by this. So all that we are going to do is that we are going to differentiate what? The q. Or we remember that technique. We are going to differentiate the q. And you multiply it by this, they become a compare coefficients and all that. Alright, so let's see how we are going to solve such. Let's see how we are going to solve such. So what we are doing now is calculus 2. We are done with ODE, the homogeneous separable. We are now at calculus 2. We are now at calculus 2. So here we know that P of u, a function of P of u is 1 over u, and Q of u is equal to u squared minus u plus what? 1. Alright, so here we need to differentiate what? This. And when you differentiate this, you get 2u minus what? 1. You get 2u minus 1. So by substitution, we are going to get a multiplying the derivative of q, which is this, plus the b. This a and the b is their value that we are going to look for it. Okay, and we divide all by what? The function of what? Q, and that is u squared minus u plus what? 1. Very good. So that is it. So now we are equating these to, let me rewrite it, let me come to this side. I hope this side is clear. Alright, so we are just equating these to 1 minus u over u squared minus u plus 1. Okay, so we know that this is identical to this. Okay, the denominators are the same, and if the denominators are the same, we equate the what? The numerators. So we equate 2u minus 1 plus what? B. Alright. So let's see what we are going to get for that. As we said, you need calculus 2. So if you haven't watched the video under calculus 2, go back and watch it. Okay. So here we now solve that. Alright. So we can see that here straightforward. Let's expand and simplify and compare coefficients. This will give you 2AU minus A plus B. Alright, so we get 1 minus U is equal to. So here, when you group like X, you can see that 2A and the U minus this will be the constant A plus what? The B. I hope you can see from there. Alright, so that will be the constant. So by comparing both sides, we can equate 2A to be equal to the coefficient of the U here. The coefficient of the U on the left hand side. And that is, it's like solving it in a partial fraction. And that is -1. So we get A to be -half. Then we go for the B. We go for the constant. And the constant here is -A plus B. -A plus B. And that one to be equate it to the left hand side here, which is what? 1. But we know that A is what? -half. So -half plus B is equal to what? So here we get half plus B is equal to what? So we get B to be equal to -1 minus what? Half. And that's going to be 3. Sorry, that's going to be half. That's going to be half. So we get A to be -half, we get B to be what? -half. Beautiful. So by substitution to this side, by substitution, alright, coming. So by substitution, watch. So by substitution to this, you now substitute -half, that is A2, 2U minus 1, plus the B, which is what? Half. All this over, please, all that we are doing is calculus 2. All this over what? U squared minus U plus 1. Alright, so that is what we have transformed this equation to. I have done that. That's what we have transformed this equation to. So simply, all that we are saying is that to integrate, where is that side? Where is this? Okay, let's move on. So we are saying that to integrate, so this is equal to -half 2U minus 1 plus half. All this over U squared minus U plus 1. So to integrate this as respect to U is the same as integrating this as respect to us, U. Beautiful. Beautiful. So that is all what it means. That is all what it means. So we are now going to focus on this side and integrate. Now here we know that here we are going to get half 2U minus 1 over U squared minus U plus what? 1. Which is plus, because we can split this. Half U squared minus U plus what? 1. Alright, du. We are still under the calculus. calculus 2. Alright, so by integration, we know that this, what we have here is a function and its what? Derivative. Don't forget that. What we have here is a function and its what? Derivative. Because if you integrate, if you differentiate this, the denominator, you are going to get this. This is calculus 2. So here you are going to get negative 2 ln u square minus u plus what? 1. Okay? Plus, here we are going to, alright, so here, so when you integrate this side, you get this, alright, and when you integrate this side, we can plug this half out and integrate it. So we are going to solve this by what? Completing the what? The squares. We solve this by completing the squares. We know these techniques in calculus 2. So we have this, and when you complete the squares, you are going to get this. And after completing the squares, you take the integration of this. And this is an, from integration of trigonometric what? Functions. We know that this is a tan inverse. And going to be what? It's going to be a tan inverse of the reciprocal of this. What is what? Square root of 4 over 3. Tan inverse of this, the whole of this, over the reciprocal of this. And that is what we are going to have. Right? So you know this from calculus what? 2. So now, when you integrate this, you get this. So straight away, coming back to where we are. We are coming back to where we are. We are coming back to where we are. We are coming back to where we are. Where we have integral of, u minus 1 over u square minus u plus 1 du to be equal to ln s plus c. Right after solving it by what? A separable, we go to this side. Hope you remember where we are. So when you integrate this, you are going to get this. So we write square root of 4 over 3 tan inverse of u minus half over square root of 3 over 4. So that is that for the left hand side, which is equal to ln s plus this. You can make it ln c. And here we get, you know, square root of, here will be given 2 over square root of 3. So tan inverse of u minus half over, here we can get 3 over square root of alright. So here we can get, it's supposed to be 3 over square root of 3 over 2. Okay. So here 2 will be square root. For here the same thing, but here it's supposed to be square root of 3 over 2. Alright? Is equal to ln cs. Ln cs. So what you do here is that take a natural log of both sides. And when you take a natural log of both sides, you get cs to be equal to e raised to the power 2 over square root of 3 tan inverse of u minus half over square root of 3 over 2, and that is what we have for that. Alright, so that is the end of this question. Let's go to the B and see how that is also going to be. The B. It's not difficult, but just don't forget your calculus 2. Just don't forget your calculus 2 and 1. Straightforward. C. We know that this is separable. So I won't verify anything again. dy minus sy dy is equal to 0. It's separable. So here we know that always is in the form dy ds is equal to a function of s and what? Y. So we make dy ds stand alone. So here we can write y squared dy is equal to sy dy. So when you divide both sides, you are going to get dy ds to be equal to dy ds. Sorry, there's a mistake somewhere. Why is this question? What's supposed to be ds? Okay, here is the ds. Alright. So that's what we are doing, and we are going to get sy over y squared. So dy ds, then you divide both sides by this. And you can see this is separable. It's separable. So we are going to get lambda squared sy over lambda squared y squared. And we are going to get s raised to the power 2 minus 2, which is lambda raised to the power 7. So this is what? A separable differential equation. So let's go straight to the point by let y to be equal to us. Or please, from the first example that we solved, when you get to that final answer, don't let the general equation be in terms of u. You will now substitute u to be equal to y over x. Please, I forgot to do that because of the process we went through. So do that for me. I'll do it here and you see how it is. So here, dy ds, you differentiate this, you get u plus s du ds. Alright? So by substitution to this side, we get u plus s du ds. U plus n du ds, and this is going to be equal to this, and this is going to be equal to this side. Alright, so we have s, but the y is what? ux, not ux. Alright, ux. Alright, so here we get u plus s du ds to be equal to ux squared over u squared s squared. Hope you can see that. Okay. So here okay, so by substitution, you differentiate this. Then wherever you see dy ds here, put this one there, and that is what we have. Alright. But here, wherever you see y, put us there. us. And now this will take away that. So u plus s du ds is going to be equal to, you can see that here we are going to get 1 over what? U. 1 over u. So s du ds is going to be equal to, we are still transforming into the separable differential equation. So all this is ODE. So 1 minus u, say this one here minus u. So to achieve the same denominator so that we can express it in separable, s du ds is going to be equal to 1 over u minus u squared over u. How you can see that? That is multiplying this by u over u. So you get u squared over what? U. So Hope I can clean this side. So we get s du ds to be equal to, here we get 1 minus u squared over u squared. Beautiful, beautiful. That is exactly what we have. U. So that is exactly what we have. So here, when you split it, du will become to what? Ds. So you can see that you have 1 over x. But here, you are going to also take the reciprocal of this, and you will get u over 1 minus what? U squared. Calculus. It is now separate. It is now separate, and the rest is calculus 2. Welcome to calculus 2. Welcome to calculus 2. So here, let's pick this side and differentiate. We know that this is just going to be ln x plus c. But what about this side? Ooh, are we forgetting? Don't forget. Here, we can let u be equal to, hey, since now we have u in there, so let's use w because 1 minus what? U squared. Alright? And when you find the w over du, that is differentiating w as respect to what? U. We are going to get here to be 0 by here. We get negative 2u. So, to make du the subject, we are going to get du to be equal to dw over negative 2u. Alright? And by substitution, you are still on the left hand side. By substitution, we get u over w, and the du is what? dw over negative 2u. So this will take away this. So you get integral of 1 over w, and the constant is negative what? Half dw. So when you integrate this, you get negative half ln w, negative half ln w, but w is equal to what? 1 minus, so we get negative half ln w is what? 1 minus what? U squared. 1 minus u squared. So that is what we have for that. So simply we have this side to be this. So that is going to be negative half ln 1 minus u squared to be equal to this side. And this side is going to give us what? Ln s plus what? C. But we can write dc as ln c. Okay. So here, negative half ln 1 minus what? U squared. But here, this one here, we can let this square this side, but let's leave it as that. So this is equal to, we can write this as ln c x. Alright. But here it's good to raise this to a power of negative half, so that we can take a natural log of what? Both sides. So we get e. That is a natural log of what? Both sides. So that is what we have for that. And now we know this will clear up this. This will clear up this. Very good. So very soon we will conclude it. So now we are going to have 1 minus u squared negative half is equal to cx. Alright. So that is the final answer for our question. So this is going to be the general solution because we have c in it. But you can still continue with it because we can write this as 1 over square root of 1 minus 1 u squared, which is equal to what? Cx. You can leave it as this, and that is a general solution. Alright. Let's look at our last example, which is the D. Okay, so let's look at the last example here, which is the D. Now, we have to show or verify before we solve. So let's continue. So we have S sine y over x minus y cos y over x dx plus s cos y over x dy to be equal to 0. Alright, so that's exactly what we have. So the first thing to do, that's exactly what we have. Alright, we know that it should be in the form dy dx to be equal to the function of s and what? Y. Alright, so let's make dy here the subject or stand alone. So we have this, we have that. Alright. And the dx is here and the dy is also what? On the other side. So what we are going to do is that let's maintain this on the left hand side and send this to the other side. So here we get s cos y over s dy to be equal to, here we are going to get negative s sine y over s minus y cos y over s dx. Yes, in this case we are using the whole board. Alright. So that is what we have. Okay. So here we can let this negative affect the inside. So when you remove these brackets, we are going to get here to be plus. Hope you can see that. And to get dy dx, to get this dy ds, you know that we have divided both sides by what? Dx. So this will go. And now we are going to have negative s sine y over s plus y cos y over s. Then we divide both sides by the whole of this. So the whole of this over s cos y over s. Yes, that's exactly what we have. So now, let's verify whether it is homogeneous or not. So you attach lambda to this. Size one. Alright, let's continue. So here, we want to verify whether it's homogeneous or not what? Homogeneous. So, like what we normally do, we attach the s and the y by what? By lambda. So here, you can see that when we attach s here by lambda, we are going to get negative s lambda, or lambda. Okay, then the sign, we attach that place by lambda, alright, plus lambda y cos lambda y over lambda x, all these over lambda s cos lambda y over lambda x. Simple. this will cancel this, this will cancel that. And now, this one too will cancel that. And you can see that here, the lambda here, and the lambda here. We can factor those lambda out. Alright? We can factor those lambda out. When you factor this lambda out, you are going to get 8 here. You are going to get lambda here over this lambda here. Over this lambda here. So we are just going to get lambda raised to the power 0. And therefore it's a homogeneous differential equation because we are having the degree to be 0. So this is a homogeneous differential equation. Therefore, we can now transform it to a separable differential equation and solve it. So you have realized that it's not always that when we have a trigonometric function in, that means that it's going to be not homogeneous. It's not like that. It depends, alright? It depends. So let's move on and do our steps. Good. So let's continue. So with this, we let y to be equal to what? Ux. Or u is equal to yx. Then the next step is that differentiate dy dx. And that is going to give you u product to u s du dx. Alright, let's move to this side. Or let's move to this side. From here we move to this side. So now, wherever you see dy dx here, replace that by this. So we get u plus s du dx to be equal to, that is dy dx, exactly what is here. Then we are going to repeat everything here. So negative s sine y over x plus y cos y over x. All this over s cos y over x. Very good. So that is that we have for that. Oh, but we have forgotten to do the substitution. I hope you can see that. We are saying that y is equal to us. That means that wherever you see y, you replace that by what? Us. Or wherever you see y, x, replace that by u. So let's go and do that. So this y over s is going to be u. This y over s is going to be u. This y over s is going to be u. But this y is going to be ux. So here plus ux. Very good. Always don't forget that. So now we have get rid of all the y's. That is the reason why we do the substitution. Wow, let's start with the gymnastics. So here, the s du ds is going to be, send this to this side, negative s sine u plus u cos, it's rather ux cos u. All this over s cos u minus the u. Now we want to maintain the same common denominator. Therefore, we have to multiply this u by s cos u over s cos u. So let's repeat that step again. Yes. Negative s all this over s cos u minus u multiplying by what? S cos u over s cos u. Why are we doing that? This and this don't change anything because this cancels this and you get 1. 1 multiplying u is the same as the u. But we want to achieve the same common denominator. So S du over S is equal to negative S sine U plus US cos U minus US cos U. All this over S cos U. Very good. So that is what we get for that. Let's continue. We want to get it in a separable. Okay, we want to get it in a separable so that we can solve to get the general solution. So here we continue. Now let's see something. We have US cos U, US cos U. Oh, very nice. You can see US cos U, and negative S sine U. Oh, then this can cancel this out. This can cancel this out. So we are just going to get S du ds to be equal to negative S sine U. All this over S cos U. Very good. Oh. So it's no more point stars, okay, because we have now simplified it. And we can still simplify this. This can cancel out. So we get S du ds is equal to, and now we also know that sine U over cos U is what? Tan U. Alright, so negative tan U. We are still on it. So we can now say that what we have there is separable. And if it's separable, then, or it's not yet separable, yes. So now let's go by it. It's just simple. We know that here we maintain the U here, we maintain the ds here. So it's like cross multiply. Now, this will move to this side. So we get 1 over tan U. Then this S2 will move to this side. Or like dividing both sides by 8. So you get 1 over what? X. But don't forget the negative. The negative. Okay. So now it is separable. So let's integrate both sides. And when we integrate both sides of this, we know that with this side, we are going to get the integral of 1 over tan is what? Cos. In case you have forgotten, this is cos U du, which is equal to the negative out. You get ln x plus c. Alright. So the only case here is that the integral of cots. And you know the integral of course already in calculus 2 that is going to be ln sine U. So when you integrate the left hand side, you get ln sine U, which is equal to, here we get ln s plus ln, don't forget the negative, ln c. Because whether C or ln is still a constant, so it's still the same thing. Alright, so from here, what should we do? We get ln sine U is equal to, we almost got ln C minus ln S. Here we get ln sine U is equal to, here, we can combine, alright, so we get ln C over X. Very good. Now we can apply our natural logarithm. E on both sides. Clear of this. Very good. So we get sine U is equal to C over X. And therefore, we can say that by cross multiplication, C is equal to S sine u. Oh, we are done, but we are not done. Now we know that u is equal to y over x. Don't forget that. So yeah, but u is equal to y over x. So wherever you see u, put y over x there, and that is the final thing to do. Alright, so you can write that here. Finally, we get c is equal to s sine y over x. So this is our general solution. Don't forget that in case an IVP is given to you or the initial value problem, when the initial value is given to you, let's say y 0 1. When you get to this side, you know what you do already. You put y to be equal to what? 1. You put x to be equal to what? 0. Then you go and find the c. And after finding the c, you come and do the substitution back. Let's try and see. Let's assume in case the initial value is given to us. So for y 0 is equal to 1, you put x to be equal to 0, you put y to be equal to 1. That will make it some way, because here for x to be equal to 0, the function will be what? Undefined. So you let me make this 1. Let me make it 1 1. Okay, 1 1. So here c is equal to s is 1 times sine 1 over 1, and we are going to get sine 1. And what is sine 1? Yeah, point of calculator, and we are going to get b in degree. Okay, you see it's approximately 0. This is approximately 0. Then let's choose a correct one. Let's choose y to be, I'm coming. Yes, assumption I'm doing so that. Alright. Let's do it this way. Let's use it to be pi over 2. Alright? Let's make it that way. So here you put x to be 1, y to be pi on 2. Yes. So let's move on. So here we get x is 1 times sine, y is pi on 2. All these over what? 1. So c is equal to sine pi on 2. And sine pi on 2, make sure you be radian. 4. Sine pi over 2 is 1. Sine pi on 2 is 1. Therefore, c is equal to 1. So by substitution here, we get c is equal to 1. So our particular solution is going to be 1 is equal to s sine y over x, and that is our final answer. Thank you. That is the end of solution to homogeneous differential equation. See you in the another video. And that one, we are going to another techniques. We are going to also look at another technique, that is exact differential equation, and you will love it. See you in that.